Hello everyone. In this lecture, we are going to see the image segmentation using the threshold method. And for this, we are not going to use the gray level images. We are going to use the black and white images. But conversion from RGB to black and white is different because here we need to perform two steps. We need to convert the RGB image to grayscale, and that using that grayscale we can convert to black and white. Now we are going to see that in this experiment, CLC clearing of console, and next reading the image. I am read of lion.jpg. Yeah, semicolon. No. For converting RGB to gray of A. This is function. And now for converting from this RGB, I mean the gray level image, right? B is. Now by using that gray level image, we can also convert to black and white using the function I mean image to BW, nothing but black and white. You need to pass the parameter B. Now, as you know, subplotting we are going to do. Let me consider it as 3 by 3 at position 1. Oh, sorry. First mention figure, subplot, and now title as original image. And now I am going to display one image after other. First I am displaying original image. Control C. At position 2 I am displaying grayscale image. Grayscale image. And at third position I am going to display the without threshold one, black and white. I mean it will take the default value B, black and white image. For this one I have used the variable C. Yeah. Now from now I am going to make use of the threshold. Threshold is nothing but as we have seen in case of the before edge detection filters, we have done one of the part where we applied in case for noises percentages, right? Those percentages we are going to make use here. Here, first parameter will be the same, nothing but the gray level image, and here you are going to give in terms of percentage. 0.8 is nothing but 80%. 80 by 100 is nothing but 0.8. At 80%, this is the threshold. And let me do similarly two more so that directly I can at end I can print all of them. And again grayscale. Now I am applying it some, let me take 0.5, nothing but 50%. And one more, let me take it as, yeah. Now one more, let me take it as 30%. And one more thing in this we are going to discuss is that complement of image. Complement in case of black and white is nothing but in black and white you know that the pixel values are always 1 and 0. And for the given image, where ones are there, there we keep zeros, and where zeros are there, there we are going to keep ones. That that resultant image is called as the complement of the given image. It can be obtained by doing 1 minus of. That is nothing but let me take it as E complement as EC, because here we can see it clearly. EC equals to 1 minus E. Nothing but EC is the complement of the image E. We have done three plottings. This is one more plotting. Let me take one more value also. For F we will do. F complement is nothing but 1 minus F. Yeah, now continuously now all we are going to print up to 3 we have used 3, 3, 4, and now here I am going to use D. D is 80% threshold. 80% threshold image. Let me copy these lines only. Control C. At position 5, 0.5, nothing but 50% threshold image, that is given by E. Let me print the threshold also here only so that it will be easy for identifying differences. And it is 50% threshold complemented image. Complemented is given of as EC. Next, at position 7, I am giving the threshold as 0.3, nothing but 30%, and I am using F. And next, this is the last image I am going to display in our output, and this is for F 30% threshold complemented image. For this, I have used this FC. Yeah. Now I am going to save it. Let me give it a name. Is the name complement? No. So let me give it as complement only. Complement image, because already the name is used. Complement. Now let me run it. Clearing of console. We didn't got output because here you can see some trace error has occurred. Where is that error? We need to identify. Yes, the reason for error is trace is not declared. That is, here I have given direct, right? We must and should mention threshold because it will not give direct black and white image. So here without threshold, if I am giving, there will be an error occurred. So let me give some threshold value as 0.1, nothing but 10%. Now the output will be correct, and there will be no error occurring now. You can see here. Yeah, because this IM to BW always expects a default threshold value. Yeah, now you can see how the differences are. This is a 10% threshold, this third image is. And if I applied 80% threshold, you can see completely black image has occurred. For 50%, you got this. I said complemented image, right? Where there is white, you can see black, and where there is black, you can see white. You can see here, there are 3 black dots, became 3 white. Here 2 dots, 2 dots. Similarly, here also 30% threshold image, 30% threshold complemented image. Where there is complete white, it becomes black, and where it is black, it becomes white. This is how we perform image segmentation using threshold method. Since this is threshold method, here we must then give a threshold value. Otherwise, as you have seen, we will get the error. And in the next lecture, we are going to see the color image histogram operations. And this session is completed with converting to, I mean, doing image segmentation using threshold method. Thank you.